So now this is the last bit, and we come back to this table. South Australian Gulfs, different locations. We focus on Spencer Gulf. Spencer Gulf is here. It's about something like 300 kilometers long, maybe 30, 40 kilometers across. So it's a large estuary. It's an inverse estuary. And so, but anyway, we're talking about tides. Tides at different locations. And here you have information for the individual tidal waves. Okay, we have the M2. It's the semi-diurnal lunar tide. We have the S2. It's the semi-diurnal solar tide. And we have the diurnal components as well. If you see these symbols, you know what the period is. It's given. It's a constant. You know the period, what the period is, okay? And you know now that the tide that you get is actually the sum of all these individual waves. Okay, so you have 4 components describing a main part of the tides. There's more than 4 tidal constituents, but these are the most important ones generally. You have to take the sum of these. And you have a phase. It's the timing between these waves, and the phase is given here. It's unfortunately also called G, but this is just the phase that you have in degrees. Okay, 360 degrees is one cycle. Okay, and you can just plug in this phase into your equations, and this gives you the time difference between the peaks of each individual component. The other bits are the tidal amplitudes. H here is not water depth. Again, you can get confusing use of symbols, but this is just from the paper. Okay, it's called H here. This is our A0 in centimeters. 68 centimeters M2 tide. Okay, so now there are 2 important features that I want to highlight. 2 features that stand out. If you just look at the numbers, you have a little bit of a feeling for the tides and tidal interference of this. Have a look at what happens in Upper Spencer Gulf. So you come from Port Lincoln. Port Lincoln is down here in the south. Okay, you have amplitudes of 23, 26, 23, and 16. Okay. All right, so if you add up these numbers, it's a meter less than a meter. Okay, is the tidal amplitude. You might get up to 1.5 meters maybe. Tidal range maximum if all play together. Okay, so now go up to Port Augusta. Look at that. 68, 74, 45, 29. There's a tidal amplification. The tidal range becomes larger. And this is exactly what we're talking about as this resonant amplification, where you get a bigger. Okay? It is very pronounced. Okay? It's a pronounced feature. So now the other feature that is pronounced. Let's compare the amplitudes of the M2 and the S2. So you look here and look at Wallaroo. Yeah, let's see, Wallaroo. I get the pointer on. Wallaroo. Oh, where's Wallaroo? Wallaroo is up here, halfway. Wallaroo, 17 centimeters, 17 centimeters. Port Victoria, 18. Whyalla, 42, 45. They are very close. Think about tidal, the interference of 2 waves. If the amplitudes are very, very close to each other, means sometimes you get twice, and at other times you get nothing. This feature is called the Dodge tide. We're having Dodge tides in South Australian Gulfs. Traditionally, Dodge tide refers only to the situation when all components cancel out each other, which might be only 1 or 2 times a year. But often the neap tides are very, very weak. Let's see what happens during the neap tides. I have some time series of tidal currents. Okay, this is of Christie's speech, something like more than a month of measurements of currents, tidal currents, horizontal currents going one way, going the other way. And this one is only the speed. The speed, sometimes strong speed, sometimes zero speed, maximum speed, and so. Okay, and you get this series, and you can see the spring tide. You get the maximum, 40 centimeters per second max, and then you get times where you get reduced speeds. Okay, this is what we call the Dodge tide, and essentially every fortnight you get something like a Dodge tide. You get some of the other tidal constituents here, for example, or you get some wind effects, okay, or density-driven effects. Okay, so all this you need to understand the key aspects of tides, and I hope that this tutorial helps you understanding tides. Hey ho, that's the end of it. Thanks.